Hi everyone, welcome back once again. Today we're going to look at question 5 and its functions, specifically focusing on hyperbola, and that is from your grade 12 November 2021 past paper. Question 5, you are given f of x is equals to minus 1 over x minus 3 plus 2. Then in 5.1 they want you to write down the equations of the asymptote. Alright, the equation of the asymptote. We know that this is a standard form for a hyperbola graph, and we have two equations of asymptote, right? So we have the vertical one and the horizontal one. Alright, so we can clearly see that this is q and it stands for our equation of asymptote. So you can write y is equals to 2, or rather you can say q is equals to 2 if you want, but normally we say y equals to 2, and another one you just x minus 3 is equals to what? Is equals to 0. Then x will be equals to what? Will be equals to 3. So those are your two equations of asymptote. 5.2, it says write down the domain of f. All right, so you know that domain, simply it's the interval of x, or rather the x values in which your graph will cover. All right, so we have determined two equations of asymptote, and this, we know that asymptote is actually the imaginary lines in which the graph will approach but will never touch. All right, so if we just simply represent our asymptote, the x-axis and this is the y-axis, and our value of a is negative, meaning our graph is going to be in the second quadrant and fourth quadrant. So you can see that the graph will cover any value of x going to the negative side, because there's this arrow there, and would also cover any value of x positive that side, except when x is equals to 3, because that's the asymptote. It approaches but it will never touch, because immediately it touch it becomes error, right? So we can say our domain, x is the element of all real numbers, but x must not be equals to what? Must not be equals to 3. So x can be any number except 3, and that's our domain of f, right? 5.3, it says determine the coordinate of the x-intercept of f, right? So in 5.3 we need the what? The x-intercept. All right, x-intercept. How do we get the x-intercept? We simply let y to be equals to 0, and so for what? For x, we know that f of x is the same as what? Is the same as y. So we're gonna let it 0, and we are basically gonna solve for x. So we have something like this. We can transpose 2 when it goes this side to be minus 2, it equals to minus 1 over x minus 3. Then we can what? We can simply cross multiply, right? So we'll have something like minus 2x minus 2 times minus 3, it's going to be positive 6, is equals to minus 1 times 1, which is minus 1. So minus 2x will be equals to minus 1 minus 6 when we transpose 6, right? So minus 2x, it will be minus 7. We divide by minus 2 both sides. Then our x will be equals to 7 over 2, which is the same as what? As 3, 5. All right, so that is our x-intercept. We can just write it clearly. So it will be 3, 5, or rather 7 over 2, 0. All right, because we let y to be 0, our x, and is 3, 5. Okay. 5.4, it says write down the coordinates of the y-intercept of f. All right, y-intercept of f. So how do we get the y-intercept? We let x to be equals to what? To be equals to 0. Then we solve for y. All right, so y equals to minus 1 over, where there is x, we're gonna let it to be 0, and we are going to solve for y. So this is minus 1 over minus 3 plus 2, right? So we can basically use our calculator to get the answer of that, and from our calculator we're gonna get 7 over 3. So the coordinate will be 0, because we let x to be 0. We start with x, remember, and followed by y, and our y, we've calculated it as 7 over 3. All right, let's lastly conclude with 5.5. Draw the graph of f, clearly show all the asymptote and the intercept with the axis. All right, so you can see that all those questions that we have answered from 5.1 to 5.4, they were just basically leading us to this question, right? That's basically how you sketch any graph. You must get the asymptote. If there are any, you must get the x-intercept, the y-intercept, and it's not necessarily to know the domain and range, but you can if you want then. But what's most important is that you must get your asymptote and your x-intercept and go and sketch the graph. And we've already calculated this, right? Remember, we got our x-intercept as what? As 7/2 and 0, right? That was our x-intercept. And we got our y-intercept as what? Our y-intercept was 0 and what? And 7/3, right? So this was our y-intercept. And we also get the asymptote, right? Asymptote, that is the imaginary line that the graph approaches but will never touch. We got y equals to 2 and we got x equals to what? Equals to 3. So with this information, we can now go and sketch a graph, right? So we are going to sketch our graph. This is x-axis and this is our what? Our y-axis. So we have a asymptote at 2, y equals to 2, so 1, 2. So we're just gonna put a dotted line to show our what? Our asymptote, and another one at x equals to what? X equals to 3. So we're gonna put our imaginary line like that, right? So then the x-intercept is 7/2, which is 3,5. So if this is 4, then 3,5 is somewhere here, right? So this is our x-intercept. Our y-intercept is 7/3, right? And 7/3 is the same as what? As 2,33. So it's somewhere there, right? Closer to 2 there. So that's our y-intercept. All right, so we can go and sketch the graph. Remember, the equation was y equals to -1/x minus 3 plus 2. Then you can see that our a is negative, meaning that our graph has to be in the second quadrant and the fourth quadrant. And you can clearly see from this point that indeed our graph is going to be there. Oh, sorry about that. Our graph is going to be here in the second quadrant and also in the what? In the fourth quadrant. Let's not forget to clearly show all the asymptote and the intercept. So this was x equals to 3. This dotted line, we are showing them the asymptote. This was y equals to 2, and we have also shown them the intercept. All right, so that's basically how you sketch the graph. Otherwise, that's all for me. Kritov, we were focusing on your question 5. Quite a very simple question that was focusing on function hyperbola. Otherwise, that's all for me. Till we meet next time, and goodbye.